In this example, we're looking at a cute little limit that has x cubed cosine of 2 over x, and we want to prove that as x goes to 0, this whole thing goes to 0. All right, so let's get down to it. We have a couple issues here. The biggest issue we can see is we have a 0 in the denominator, and so things are going to be a little bit funky. We also have a x to the third, so something is going to 0, so that's a polynomial, but we also have this cosine of 2 over x, and it's hard to see what's going to happen because the trig function is going to battle it out with the polynomial. Whenever you have something like this, a trig function inside of a limit, it should signal one thing to you: squeeze theorem. So it's not always going to be a solution to have the squeeze theorem, but a lot of times it is. And so in this case, that's exactly what we're going to do. Because we have this trig in here and something attached to it, we're going to see what happens when we apply the squeeze theorem. All right, so working with the squeeze theorem, the first thing that we're going to do is we're going to start off with our basic trig function. So that was cosine of 2 over x, and we know cosine is always bounded above by +1 and below by -1. And that's what's going to allow us to use the squeeze theorem, is we have those definite bounds for it. Next thing that we're going to do is we're going to build up our function inside. So we're going to multiply by x cubed, and we're going to do that for every single part of our inequality here, all 3 parts. So that'll give us a negative x cubed is less than or equal to x cubed cosine of 2 divided by x, which is less than or equal to x cubed. Next thing that we're going to do is we are going to take the limit as x goes to 0. So as x goes to 0, we know that our polynomial is also going to 0 on both the upper and the lower bounds, which forces the stuff in the middle to also go to 0. So in this case, 0 is going to be our solution, and we can say by squeeze theorem, we always want to mention that we're using the squeeze theorem, the solution is going to be 0. We can say our limit x goes to 0 of x cubed cosine of x over 2 is equal to 0. So there's our nice little proof, and it works out beautifully. Thanks for listening.